Oi. Oi, oi. by one.
Good morning, everybody. I'm going to be chair during this day, this last great day. So we are having a good shot of coffee with coding and exciting things to do with data. And so get ready with your computers and let's start.
Okay, thank you, Professor Genoveva. Good morning, everyone. Today we will continue this brief tutorial. In this morning, I updated the repository with 2 new applications I thought about yesterday, and I changed. So I introduced an examples about the IFRN Open Data Initiative, where the our university open all data for everyone. And I collected data to my car using a device. Just take the 1 minute. One minute. Okay, I put this device in my car and I collected data and I save in a file and I share the all informations with you. It's very interesting. Yeah, at the night yesterday. Yeah. When I go back to home. Yeah. So yesterday, today we will lead with 3 problems here. The first one will be the IFRN. The next one is connected vehicle, and we will finish the tutorial with the analyzing of the Uber behavior here in Natal, and to creating amazing color path maps using GeoJSON and some metrics. So in the first one, let me see here, faculty members. As I said, sorry. Okay, just a minute. Right. So, as I said before, the IFRN recently available open data initiative. Unfortunately, these data are in Portuguese, but I can understand, no problem. We have interesting data here, data sets, My focus in this tutorial is just on proof of concept, of course, because of the time, but I would like to focus in the education data set. Is this one. After navigating this link, we have information about the curricular components, about the everything course, about the students, about the faculty members, technicals, professors, and so on. It's really interesting to understand this data. You can identify bottlenecks if a specific component has some problems with the grades, for example, if there is a bottleneck in a specific course, it's good. My motivation here is to understanding the faculty members' behavior, it's not behavior, but the worked in years to ever remember. Just find this data set here. I think it's not here. People. Here. In Portuguese is servidores, but will be faculty members. In this data set, it was updated a few years ago, in the 8th November. We have information about the colleagues. There is information about the unique ID code. There is the name of the member. This is very interesting because you can, like motivation, you can develop an approach to understand, for example, the gender gap between the members and between the students. For example, to understand whether the male and female students are more distributed around the course. This is very important, in my opinion. We have the type of the position here. We have the current status of the position, if that guy is in the beginning of the career, in the middle one, or in the last of the year. I discovered here some Highlanders guys in IFRN because there is a guy more than 50 years in the public service. This is amazing. It's my hero. And we have the department where the colleague is. We have the admission date, and we have his ignition date too. So we can discover the time of work in years, for example. So my personal motivation in this example, was to investigate the trend of hiring teachers over the years. This correlate with the history of Brazil, because you can understand when the government to invest to hiring people or not. And I would like to investigate the categories of teacher by years worked. This is very interesting to identify if the university is more younger or more mature. So the first step is to import the package, of course. In this specific example, we use the pandas and data type. Pandas, it's a tabular data structure to reading with data. We need to work with data time and to calculate the time of the years worked in years. And we need to print statistical graphs. So in Python there is an amazing package to work with statistical graphics. The name is Seaborn. Just type here Seaborn. Seaborn has a lot of examples to create statistical graph. It's so easy to use. In general, you just use a few lines of codes, 5 or 6 lines of codes to create an amazing graphs. So I need to execute the cell. There is a shortcut. It's just to type Shift Enter or Shift Return, depending on your machine. Or you can execute the cell just to clicking in this button here. Okay. So the first thing is to import and collect the data. Here I create a link in the bit.do website just to put a link more easy to understand, because you go in the IFRN site here and copy this link. It's very complex. Okay. So here, go ahead. Here we will have time to load, because this file, okay, it's not big, but it's has some megabytes here. From the data set, you can see here interesting things. You can note the columns. There are a lot of colors here. There's a column to verify the faculty member, the name, and we have interesting in 2 last ones. That is the admission data and resignation data. Okay. So the next step is to preparing this data set to make analysis. I investigate the unique categories to understand what kind of type of members are in the data set. Here we have basically 2, management guys and the teachers. Here I don't know why the type of member has a lot of blank space here. We need to clean them. I don't know. So okay, execute it. And here I'm interested just to know information about the teachers here. So my motivation. The other one is important too, of course. But in this example, I will just analyze the professor's data. Here in this cell, I do filtering just to select teachers. Here I try to translate the column to English. I filter in the admission column just the year. That is a portion I'm interested in, and I take the part of the year in the resignation time, and I do a very simple calc to be sure how many years an colleague worked. Okay. Here I create different data science to take the hiding and resignation. If I print here, this is a tip in Jupyter Notebook. You can create cells above and below. When the cells is selected, you just need to type A or B in keyboard. In this case, I would like to create a cell below, so I will type it B, and cell was created. So I would like to analyze what this value of variable hiding. It's just to type it. Of course, Jupyter has an auto-completed functionalities. It's just to type tab, and I will execute that. So hiding here, it's a temporal series with informations, how many colleagues were hiring in that year. So the first members of the university was hiring in 1954. 3 guys, the 3 first guys in the university. So if you went, you can hide in this information. It's just to click here. Are tips for after the tutorial. Okay, I execute the designation the same way. You can see here designation values. You can note that there's the first designation was just in 1968. I don't know the motivation, the origins. So we need to create another data set using these informations, the hiring, the designation, and after that we can create a column to balance, to make sure how many members exist in a specific year. So I create, based in 2 variables, I create another data frame, which name is balance here, and you can see the structure of this data frame. Pandas has a very interesting method that is head or tail. Here I use head just to see how the structure is. For example, you can see in the first rows the number of hiring guys and the designation. Of course, here is not a number because in this year we not have doesn't designations. So if you want to see all data sets, you can just to print the data set here. You have all informations about. Of course, this is not a good way to visualize the data. No? You need a graphic. So the next step is create here a new column. The idea is to calculate the balance, the number of the teachers, active members in a specific year. So we need to create a new column here and to process this one minus this one here. So first of all, I will replace the denoted number by a 0 just here, and after that I create a new column. If you would like to see here balance, so it was created a new column here. Of course, this is just zeros values we need to process. And here in this cell we can iterate for all rows in the data frame and calculate that correct values in that column. After that we have correct number of active members by year in the university. So I would like to see today, no? Let's print the detail here. So nowadays in IFRN we have 2,343 professors, almost 2,000. It's a big number. I don't know these numbers when compared to the IFRN, who knows? But this analysis, of course, this is just a proof of concept, okay? But this analysis, it's important to make decisions for the institution. For example, how many professors has time to have retired today? This is important because we need to contract another guys. So, given that we have the completely data set, we can create graphics about that. So here we load the Seaborn features, and after that, in just one line, you can create a graph. Here we try to create a time series graph using this column as reference and the x, that is the years, as the x-axis, and put it on your x label. Okay, the result is this one. This graphic show a little bit about the Brazilian history. So, 40 years ago, we have a fast growth of the hiring of the teacher, and we reach a plateau here, whereas in general the government stopped the hiring during the 80s until to 90s. In the FHC government having problems here, and like or not, during the PT administration, we have a growth of hiring of teachers in the institution, and after that I don't know what will happen. But the thing is that's not good. This is very interesting because it's true. It's tell a little bit about our history. So my next motivation is to understand. Okay, this is the current state of the professor's numbers, but I would like to understand if the number of teachers are in the start of the career, or in the end of the career, or in the middle one. This is important, very important. So I investigated. The first step was identify what the status of the members in the data set. Here we have two ones, of course, active and retired. I would like to filter in just the active guys here. It's just to do a filter. And I would like to, of course, just I show dot head. If the guy is active, the resignation year is not a number because that guy is active. So I need to calculate, to replace the resignation year by the 2017, this year, to can calculate how many years a colleague worked. So I proceeded this, and like that, just a minute. You can see here. You can see here in this last column I have the number of years worked. For example, that member here has 44 years worked. It's a lot of years. Let me see who is it. It's Abimael. It's okay. I think Abimael is retired in the next 2 or 5 years. Okay, then the final step is to create an graphic using the histogram of the years worked. You can see here we have a lot of guys that worked until 10 years. This is good. This reflects the reality in the last 10 years, whereas the government invests to hire young people to the university. Here, in the tail of the distribution, we have the Highlanders guys here, that professors more than 30 years worked. It's interesting to know that. And we have the other ones in the medium of the career, but the great number of the people are in the start of the career. So the last motivation here, I would like to understand how many guys are in the top of the career. It's similar to catedrático professor, titular professor in Portuguese. So I will investigate the status of career here. We have a lot of positions, depending on the career, of course, but the titular is the top of both of them, and I will create an histogram about that. And you can see you have 200 professors as titular, approximately 18% of the members of the university are titular, and almost 30% are younger adjunto, is the first category, after the PhD, of course. So, this is, I finished this part. As you can see, this is just some proof of concept. You can do amazing things with data, and it's just to show the potential of you can create using simple analysis. Okay. The next part of the talk will be about vehicle. I collected data in my own vehicle. This data was collected using, like I said, using this device. This device is an OBD device, on-board diagnosis device. In Brazil, since 2010, all cars in Brazil has interface to this component. United States was since 1996. So Brazil always get the things with a delay. In this case, 14 years of delay, but no problem. This is very interesting because you can collect all sensors in real time of the cars. For example, you can identify, including the quality of the fuel in real time, without any equipment of the gas. This is amazing. So this is another proof of concept. We need to some packages here. I use of course I forgot. I use an applications that there is an amazing project in GitHub. It's just a minute, just a find here. So in this project, it's an open project, Android OBD reader. You can generate an APK and install in your mobile phone, and after that, it's just to connect the Bluetooth of your mobile phone with this device and collect the data and generate an CSV file. It's very simple. Okay. What I did was I took the CSV and put in this repository, and now we analyze the data. Okay. I think the the packages here is the same what used in the previous examples. The CSV, I collected in another situation too, but the CSV it's like that. Oh no, you can open, no problem. It's very complicated to analyze in here, so let me show here. It's better. Okay, I put in a folder and I can read then use the pandas functions to read on CSV. I think okay. So if I would like to see the columns of data set, you can print that. There's a lot of columns here. Just show the data for you. Vehicle is 0, for example. So we have a lot of information here. We have a data time, the latitude and longitude, where is the information was took. The vehicle ID, in this case my vehicle, it's my plate here. We have information about the sensors like barometer, pressure, and engine temperature. This is very important. I remember now, just to not forget, there is a command here that's very interesting, that is ATRV. What does mean ATRV? This command take the information about the battery of the vehicle. This is so good because you can monitor the battery. If the battery decreases a little, this means that you have a problem soon. This is very important because you can maintain your car before a fail happen. You know? So the engine temperature is a good sensor to understand if your car has some problem. If the behavior is maintained along the time, is good. Some cars have fuel level. This is not my case. You can understand also the engine load. If you have in Portuguese we has a word for that, pé pesado. You consume very fuel. You have the information about temperature, pressure, and so on, and of course velocity. You know, velocity is important. You can information about the engine runtime. You can take information about throttle position. Throttle in Portuguese is known as butterfly. I don't know. Borboleta is the pedal, the angle of pedal of your car. You have another information including the chassis of the car. It's the VIN code. So, okay, we have a lot of information. In this case, my motivation is I would like to create a heat map with the velocity of my car during the test. If you have an altruistic idea, you can measure the level of CO2, the pollution that your car emitted along the travel. If everyone in a collaborative platform can share this information, you can create a platform to measure the pollution of the city in real time. Okay, this is hard to happen? I think so, but it's possible. Okay, let's continue because of the time. Here I filter in just some columns that I'm most interested in. This case, I print it here. I visualize some information here. as you can see, I have challenges to clean here because, for example, the engine temperature has an C. I will actually remove it, that character. And in engine load, we have the unit here in percentage. We need to remove that. In engine RPM, you have the unit 2. Mass F function is this parameter. It's so important because based in this information you can detect if the fuel is good or not. In Brazilian case, this is very important because some places are very strange. And the angle of throttle. Okay. Let me see. In this cell, I will not explain, of course, because there are a lot of details, but I removed the undesired characters. Just to show the final data set with cleaning the data set. Okay. We need to remove undesired line rows here because some of them has errors. You can analyze after, and here is just to eliminate the null values, to convert the data types for the more convenience types and a cast. And here we almost there. We need to remove this column because it is not really necessary. And after we have the final data set. Okay? And the final step is to create an heat map with the metric that you want. In this case, I'm using the velocity, the speed of the car. And here's the map. I'm starting taking information here. This is very close to Faixa de Gaza neighborhood. Where do you live? Of course, in red color we have the higher velocities here. The maximum was in 92 velocity. Probably here. So, if a lot of people share information like that, you can take information about the transit and about the urban mobilities. So, as you can see, it's not complicated creating heat map like that. Okay. Feel free to do questions, okay? This is a very interactive tutorial. So it's very important that everyone trying to reproduce these examples after the tutorial. Of course, because the time in real time is not possible, but after that, 1 week later, you can to see with more calm and to understand that all codes. Okay. This repository will be maintained in the GitHub, so we don't have problem. Okay, in the last part of the tutorial, I would like to show a proof of concept that we executed during 23 days, the last 23 days in Natal, to be sure the behavior of Uber here in some neighborhoods was a very interesting experiment, and I'll show you what you did. Okay. I updated this repository in this morning, but it's the same of what I showed yesterday. Okay. Here we need a little bit more time to explain with more calm. Okay, the first motivation here was to trying to understand how the estimation of population is currently in our states. So we have a National Institute for Geography and Statistics that maintain all data about the Brazil, almost all data, because someone is a black box. But the idea of the site is good, but sometimes it's difficult to take the data because it's a little bit messy where the information are. So we have a very interesting data set here about, let me see, population, just fine. I find it. Okay. Estimation of population. Good. We have estimation of a lot of years. I'm interested in this year. I think this is estimation because in this year we don't have census, you know. Okay, we have informations in different types of files here. To follow the same procedure, I will consider just the CSV. Okay, what I did, I take this data set and I uploaded it to the repository, the GitHub, and it's here. So my motivation was creating cloud path map using this data. And cloud path maps is a thematic maps like that, the Australia map. You can create polygons. I suppose that here is the state of one, and you paint these polygons with a color based on specific metric, for example, the population. So this was my first motivation here, and to learn how to do that, of course. Here we need to import interesting packages like JSON. We will use GeoJSON format here. That is a JSON for geographic units. You will need some package to painting, and of course to draw the polygons. It's so easy to create that kind of maps. The learning curve is so high. In a little days you can reproduce almost all examples. So the first step is of course importing the packages. That data set I said I uploaded to GitHub. The first step is to, of course, to read in a data frame. Just to see here, we can see the data set. We have the state code. There is another code here. The name of city, municipality, and the estimation of population. Here, the first lines, of course, is in Roraima state, but we are interested in Rio Grande do Norte state, now state. So I changed the columns to English. Okay, and in this cell I filtering the data set to just show the Rio Grande do Norte state here. And I sorted the population column to identify who was the top one, the top 10. Let me see. Sorry. Top 10. I need to use the parameter 10. The top 10 cities, most populated cities in Rio Grande do Norte is Natal, of course, Mossoró, Parnamirim, São Gonçalo do Amarante, Macaíba, Ceará Mirim, Caicó, Açu, Currais Novos, Marromtal e São José do Mipipu. Top 10. I show 10 just to show Currais Novos. But you can see here Natal is an outlier when compared with the population, of course. In the contrary side, the cities has an average for 30,000 inhabitants. Okay. Good practice is to analyze the data set to know if data set has missing values. You can see here we have 167 cities in the Rio Grande do Norte state. Okay, so this is just the data set with the metrics, that is the estimation of population. Now we need to create maps. We need to create chloropleth maps. So there is a very nice project in the GitHub, which name is GeoData BR. So in this project, angel guy draw all polygons of all cities in Brazil. So if you take the Rio Grande do Norte state here, you can see the chloropleth map to Rio Grande do Norte. If you see the source of code here, you can see a JSON file. In this file you have a lot of tests, of course, but you have an extruder here. You have features, here it's better. You have features, properties. In properties you have the name of the city. You have the geometry features, where is the draw of that city. So we can use this information to draw that picture. This is what I did. Okay. The next step is to read that file. I just use the Rio Grande do Norte file here. I will import using JSON package that file. Here is the JSON. Like I said, that file has different features. So I discovered in the worst way that some cities change the name in our state. For example, Serra Caiada, the name, but it was Juscelino, Mr. President. But when I was creating the graph, I got an error. When I see the error, I see that the name is not the same of the IBGE. Okay, Serra Caiada is Serra Caiada nowadays. Here I changed the name to Serra Caiada. In this looping, I'm navigating the features. I'm in the root features, and another one's in the name of the features. In this cell, I can print all cities in that GeoJSON. I print all cities and put in a list here just to use after in my analysis. And after that, I could reproduce the same draw of that picture in GitHub. The graphic is very simple. You need to create a volume map with the started point that I don't remember what the point is, but I think is in the Natal. After that, you use the function GeoJSON in folio 1 and added that JSON to that map here. You create map here, the M variable, and here you use the same map in the parameter of the function. Okay, this is the first step. Create and color path map. The next step is to coloring that sees a specific color based on population of that city. Okay, here I'm print again the data set just to see what's the values, and here I create another map. I create a scale. It's important to create a scale to give different colors based on population. Here we could have a problem because Natal, like I said, is an outlier, you know. So I divided here the maximum value by 4 just to give an unfair approach to see the population of another cities, basically more precisely to see the Novos scholars. So I create the scale, and after that I create the color map, color path map using colors. It's necessary to pass the GeoJSON, of course. You need to pass your data set, your data frame, that is this data frame. You need to inform the columns are you using. Here is the name of the city and the population, of course, city and population. You need to inform the features in the GeoJSON are you using. In this case, is the name of the city in GeoJSON. So that name needs to be the same of that name here in this column. So you can fix that. Here you can choose the color partner what you like to use. If you don't know what parameter is just to use another tip in Jupyter. It's just to type in the function Shift Tab and help will open. You can see here in the plus icon. Just a minute here. You have a lot of options to use colors. I just chose the red because the red is similar to hard. Okay. You need to put the name of layer you will create and another information. Okay. I'll execute that. You can see now a more statistical graph about the population in our states. Natal and also in this case are highlighted here. Grenoble is not, unfortunately. I'm trying. But we have another candidates to Rouge cities in our state. Okay. The next motivation was to define who are the cities. So I created some points in that polygons to show and pop up information about the name of the cities. So we need to looping in all polygons and to create some cycles marker in that polygons. And we have this map now with pop-up. Of course, this is Mossoró. Of course, this is Grenoble. And of course, this is Natal. Okay? Natal, Ceará Mirim, Caicó, and so on. So if do not want to show this information, you can hide them. Just click in the layer. This is so good because you create diverse layers and merge them using some statistical or I don't know machine learning approach and create a new metrics to evaluate your region. This is so interesting. Okay. Now I would like my next motivation was to study the Natal. So in that project GeoJSON GeoData PR, we have the GeoJSON about the cities in the Rio Grande do Norte state. But my motivation now is to understand Natal. So where is information about Natal? We don't. So I discovered this project here. In this project, you can use a specific language here. You can extract information in the all city or region. It's just to specify what you want here, and you can collect information. In my case, I would like to extract information like that, the Natal neighborhoods. So I got an I got a JSON file of these neighborhoods, and I proceeded in the same analysis. Okay, you need to inform here Natal. Let me reproduce. In real time is better, no? So you can take this information here, you can save that, and GeoJSON is saved about this draw. This is so easy. Okay, you do the same procedure. You load the GeoJSON. You can see how the GeoJSON is configured. Again, we have a lot of features, and we have a geometry about the draw with latitude and longitude, and you have the type, you have the properties, you have the name of the city and the name of neighborhood. Pitimbu, coincidence is where I live. Okay. In this cell, I'll investigate the list of all neighbors in Natal. Actually, we have 36 neighborhoods in Natal. Some names I don't know. So my next motivation was create random points in Natal, because I like to make spoiler I back in the cell. I read this notice. I read this notice here that I think very curious. In this notice, the journalist writing, UB seems to offer better services in areas with more white people in a suburb neighborhoods. So after read this notice, I thought it will be the same in Natal, for example. So I would like to investigate if some neighborhoods in Natal have similar problems. This was my hypothesis. The idea is in a suburb area, the Uber spent more time to arrive there because the distance or because the neighborhood is dangerous. I don't know. This was my motivation. So to do that, I need to create handle points in a specific neighborhood. So I create a function to spread and depending on the certain number of the points in the neighborhood. These functions did that. I'm sorry. Okay. I need to run this first. Okay. And after that, I chosen 3 points to spread in the neighborhood, and the result is this. Okay. This is very interesting. So the idea is to use the Uber API to collect information about these points during a certain period of time. In this case was 23 days. But idea is to run this for, I don't know, 6 months, 1 year, and so on. Okay, I can do that. But I would like to do that. The next one. How did that? The first step was to understand how the UB API working. So it's very easy to. Uber has centrally opened your API for everyone. You just need to create an account here. I will show. Navigate to the site, create an account, and create an application. After that, three steps. You just copy the 7 token and write. It's done. After that, of course, you need to install the Uber Rides package. So after install, you need to create. You inform your key here. I recommend everyone to update the GitHub repository because I changed a lot of things this morning. It's just to type it git pull and you get the updates. So we need to connect to connect to the server using your key. After that, just a minute. In this step, let's discover the position of IFRN. To give a more precise example, maps. IFRN is here, just here. I will copy this information. Okay, latitude and longitude.
Okay, this is the IFRN. When I executed this, this command will find all Uber products available in this location. In this case, let me see. Let me print in a more visual ways. Okay, we have basically we have here two Uber products here. The first one is UberX, the low-cost Uber, and the another one is Uber Select. I think it's for all Natal, no? I don't know. Just both, yeah. In other places you have another kind of, I forgot the name. Okay, so we have two products here, around here. In each product we have an key. This key is important to collect information about this product, and another one is this key. Okay, I'm looking to the time, but we have time. Get price and time estimates. Unfortunately, the Uber has a limited number of the methods, but it's enough. What I would like to do. The first one is the estimation of the price. You need to inform an origin position and the destination. Would you like simulate here how much is to go to the airport just now? Let me see. This is the start latitude in front of the IFRN. Okay, let's discover airport. Natal. It's here. Yeah. Yeah. Okay. What's the information? So I take the data. Okay. And okay. In a few minutes we'll discover how much it is. Okay. In this method you inform the origin and destination, and you key in the Uber, you do a request for the server, and after that you can take the answer. Based on this answer, the travel will cost almost 40 reais. It's a good. It's okay. Using the UberX and using the Uber Select a little bit more, almost 48 or 60. And the time it's around the same, of course, 2,820 seconds. This is how many time. So what you can do with this information is imagination can answer, but you do everything, a lot of things. So you can take the prices and so on. Another function provided by the Uber API is the get picket time estimation, or ATA. ATA is the estimation time to arrive how many times the Uber spend to arrive in your location. For example, if I put the information about the IFRN in front of the IFRN, in average, how many times the Uber will spend. Just I copy the information about the IFRN here. To do this is necessary to inform the key of the product Uber X or Uber Select. Would you like? Here, just change here and here. So let me see. Okay. Now the time will be 180 seconds, 100 seconds to be here, almost 3 minutes. It's okay. Yesterday this is not the time, but this is an average that you'll be calculate using some algorithm. Okay, we have limitations, of course, to use this API. The API support until 2,000 requests per hour. It's a lot of number. You can do many things, and now idea was to create a program to execute during 2 weeks and to collect information about all that points I mentioned it, with informations about the estimation time to arrive for each point of them, and to understand if you have in Natal some neighborhoods where the Uber need to a little bit more time to arrive in the destination. No, sorry, in the place. So I used this problem in my class last week, 3 last weeks more precisely, and some students solved that. I shared the answer of the problem, and I just to reproduce the data set of that students did it. In this CSV there are information about all collect of data. You just read the data frame to gain time, of course, and you can see here you have 23 days since the first collected. The last collected was in 31 October. This data set has around approximately 200,000 lines of CSV. It's a lot of tests, and we did the analysis. The first one was to pivot the table and to discover in all neighborhoods the average time to arrive in a destination, in a point. So you can see here some neighborhoods like Capim Macio. The Uber is almost the Hyperloop. You know, it's almost instantaneous. It's the Uber needs a small time to arrive. On the other hand, in other ones like Guararapes, the number is so high when compared with Capim Macio. Okay, I need to do some changes here in the data set. I create a map. I create a scale of the maximums and maximums, minimum and maximum value, and I create the map. In this map, we can see some neighborhoods has need to more time. For example, this one and here. This is in the north zone. This is in the south zone. Here's in Ponta Negra. Ponta Negra is a touristic place in the city. For my surprise, in Ponta Negra we have need a little bit more time. I don't know what's the cause, but I put some marks to can see information about the name of the neighborhood is the average time of that place. You can to hide in some information if you want. So the results were similar to that news that journalists writing. I think some suburb neighborhoods need more time. I don't know the cause. I suppose that the infrastructure in that place are more limited. Despite of in North Zone, we have good results here to the probably Potengi neighborhood. Opa. I think it's Potengi, but this click is not good. It's Potengi, believe me. One day I get. Yeah. No. Let me see another if you have a problem. Anyway, it's working. Believe it. Okay. Yes, we can. Uber named surging. There's a word for that. Surging. I think Uber use this word when a lot of people call the Uber taxis. Yeah, I suppose that makes sense. Okay, we have problem with the pop-up here, including the pop-up is some problem in Cloudpath in a GitHub repository of the Folium that guys are working nowadays to improve that functionalities. I think the next months we have more about that. So I think this is the last part of our tutorial. My goal was show in this brief tutorial just ideas what to do using approach less is more. You can create aesthetical plots using a few lines of codes, and you can use the public data sets available in everywhere to create values and in a way to help people, to help management, to help the staffs to think about in strategies to improve the city and so on. I hope everyone have fun with these examples, and all codes will be shared in my GitHub. You can clone that and adapt and use what you want. This is not on it. It's open, and that's all. Okay. Everyone understand everything.
I will do a question.
Good.
It's EMD. You have a supercomputer, and I would like to know if you already used Anaconda or another software framework on the supercomputer to solve some problems or to do some experiments. And if the integration was easy, was good.
Yes, you have a supercomputer in the IMD. It's open for everyone to use it. It's just necessary to do an count and has some procedure, but it's open. I'm trying. I intend to. I intend to use the the supercomputer because now idea is create bots in a good way, not to scrap methodology to create, I don't know, 100 bots to collect the information, just not to obey, but another APIs, collect informations, and after that process them. The supercomputer, it's good to processing, not to collecting. In collecting, you can use the cloud just to collect the data, and after that, you can use the supercomputer to analyze that. This is idea, no? But the supercomputer has good tools to process that data. It's possible, I think.
Thanks.
Good morning, everyone. Do you have some project to analyze the traffic, the terrible traffic here in Natal?
Yes, the question of 1 million of reais. Not yet. One student of mine worked with this problem in Dublin city, but in that time the companies hiring him and go out. But I think it's a challenge problem to lead with, but I'm not yet working that.
I have other question about the Uber. Uber has the dynamic tax in some schedule. Do you have an idea to analyze the situation, the dynamic tax, the API you can retrieve this data?
Yes, not directly, but it's possible. Including this is a very good project and future work because
sometimes we have the price.
Yes, it's dynamic. For example, let's consider the IFRN. You put a point in IFRN and random points like destination. You can measure in a temporal series and to understand how the prices grow and not. Yes, it's a journal paper. You can do that. Okay.
Hi, Ivanovich. About the open data, do you know if Waze provides the data about? In my mind right now, I think the real time that you can collect it about Waze, there are a lot of people, including the Uber. I think most of the Uber riders use Waze to trace the map.
Yes, good question. I don't know the way of Uber collected data, but in a research I did, I noticed the Uber sell the data if you went. You know, it's not the Waze. No, sorry, the Waze. Sorry, I confunded that. I went to say Waze. I don't know how the Waze collect the data, but the Waze sell the data if you went. It's not free, unfortunately. But we create another one. For example, just an idea. If open idea, open answer. Today, when you buy something in Brazil, you went on fiscal. What's the name? If the store give you in this document, you have a QR code. You know, if you read this QR code, you have you are connected to a website where's the all information about the products, the name of the product, the price of the product. If everyone shared this information from the same place, you can to identify in real time the price of the products. Suppose that you go to the Nordestão and you create a list of products, you know where is the most cheaper place to buy that list. This is so amazing. For example, if everyone to share the price of the fuel, you know where is the most cheap place to fill your car. Yes, ways. Yeah. Yeah, but this is the secret of the Waze. It's of course, in my opinion, it's a win-win platform. You win because you share your information, geographic information, and you win when you discover the best path to go. In that idea, why you take a picture and share your information? Because if you do, you can save money, for example. It's just an idea. I'm thinking you ask about the open. I remember that.
Well, I think that you have room around the coffee to continue the discussion. I thank you very much, Ivanovic, for the tutorial and for opening ideas in the minds of everyone. Thank you very much. We will be back in 30 minutes.
Não sou programador. Não sou programador. Eu sou programador de Java. Estou estudando Python para ser curso. A dúvida é a seguinte: você usou o Jupyter para fazer tudo isso e é facilmente integrável todas essas questões na conta com qualquer outro IDE, o Salsify, o PyCharm, né? E Jupyter tu usa basicamente para fazer as aplicações e as aplicações dessa. Não, no dia a dia mesmo. Programa em cima dele. Claro, se quer fazer um programa que quer fazer ele é para você fazer as análises. Aqui tem muitas coisas assim. Eu trabalho já mas eu usei muito já, não sei bem. Eu queria fazer alguma coisa, mas escrevi com os esquemas. A minha dúvida maior é assim: o cara vai ficar no browser, lá programando, e vendo os resultados, ou fazer isso no IDE? Não, a ideia é Python, notebook, literatura, alguma coisa. Posso tirar aqui? Ah, sim. Beleza, obrigado. Valeu, nem que conversa mais ali embaixo. Eu ia até comentar, eu estava olhando, aí os preços eu dividi por manhã, tarde e noite, entendeu? Os preços da noite.
acheter en plus celle qui a les claviers, parce que si tu as Office, c'est plus que non, c'est regarde. Oui. Donc, si tu veux comme ça, ton clavier. Oui, et bon, l'avion et tout, c'est souvent. Oui, parce que t'as pas beaucoup de place avec l'ordi et comme ça. Donc, send that to a local newspaper so that they know that you are also doing actions on smart city. Pas commercial, projet, agent. Projet, agent. Oui. So we're going to start smoothly. It is time to come back to the last but not least keynote of the school. And not least because of many reasons. And one of the reasons is because she's going to tell us how to look smart. So I already have my glasses to start being in the mood. No, without the joke, I am very pleased to introduce Dr. Elsa Negre, who is Associate Professor at Université Paris-Dauphine in Paris, in France. She obtained her PhD in 2009 from Université François Rabelais de Tours in France. Then she did 2 postdoctoral internships, one at University of Quebec, I don't know how to pronounce it, in Canada, and another one in Laboratoire d'Informatique in Nantes Atlantique. As I said, she's currently Associate Professor at University Paris-Dauphine. I will not go through the interests because of research interests, because she's going to share with us some of her expertise and interests, and so I will let her use the stage in order to talk about cities and smartness. Thank you very much.
Okay, so this presentation is not how to become smart, not as a person, but as a city. Okay, so for the structure of the presentation, okay, it's organized in a sequential way with 2 big parts. The first one is the theoretical part, with the premises and introduction into the context of smart city, different definitions, and our vision in my laboratory of what is a smart city. And then we will discuss some more practical part. Okay, so the first part is smart cities. At present, several cities all around the world define themselves like smart city, but the definition is far from to be well stated. There is no real definition of what is a smart city. Indeed, these cities use the word smart to name a wide strategy, including a large spectrum of heterogeneous solutions involving several different technologies. A comprehensive vision of the smart city lacks so as a roadmap to implement it or a set of performance indicators to evaluate the success or the failure of smart initiatives. In the meantime, cities are also committed to create an ICT infrastructure to support big data collection, processing, communications between citizens and institutions, private and public services, and so on. This panorama is quite confused, in fact, and it impacts on the quality and effectiveness of public and private programs to reach measurable and useful results by smart city initiatives. And to better drive city strategies, choices, investments, a clear definition of smart cities need able to understand this important phenomenon and to support strategic decisions. During the latest years, population in cities has been growing faster and faster. At present, 52% of world population lives in cities that occupy around 2% of the global space of the Earth. By 2050, 70% of population will live in cities. This phenomenon is continuously increasing, and it is spread all over the 5 continents. Even if some countries in particular could have a dramatic augment in urban population during the next 20 years. For example, China, South Korea, Mexico, Brazil, and several African countries, for example. Today's urban population is 3.3 billion, and by United Nations calculation, it is expected to double by 2050. It means that 2 out of every 3 people will live in the city in 2050. So this phenomenon regards not only large cities, but also the medium ones and all countries in the world. Okay, here we have a figure where we can see the world situation of urban density and population. There are 24 cities over 10 million inhabitants. Several countries, okay, the yellow circles, have more than 75% of population in cities. And many others are predominantly urban, too, with more than 50% of people living in the metropolitan area. This is the violet circle. So, as we say before, this phenomenon regards not only large cities, but also the medium ones. And seeing as mega cities such as, I don't know, New York, London, Beijing, Mumbai, Mexico City, they can only grow so much. Most of the urban growth will take place in smaller cities, and the WWF predicts that the highest growth rate of 4.20% will occur in cities with fewer than 1 million residents. Cities with more than 1 million residents will grow at rates less than 2% or something like that. Whenever in the history, the city has been the crucial space where economic and cultural development has happened. And nowadays, the post-industrial development is more and more concentrated in the urban space. However, the larger and larger dimension of cities all over the world poses the dramatic problem of their management. Pollution, overpopulation, scarcity of natural resources, food, difficulties in supplying public and private services are only some of the urgent challenges to face. Okay, so what is a city, in fact? It is a complex notion where some concepts overlap. So I try to give some points. So to face this complexity, it could be useful to start from the analysis of the concept of a city, especially identifying some components functional to support a smart city implementation. Okay, so as shown here, we will consider 4 basic elements to compose the city. We have the land, infrastructure, people, and government. Okay, land, that is the territory on which the city is built, the geographical area on which the city has its own boundaries. Infrastructures, that is all the managerial or technological facilities supporting the urban life, such as public and private buildings, streets, transport, production sites, and so on. People, that is the citizen living in the city, but also works, studies in the city, or comes to visit the city or to enjoy some cultural events or so on. And government is the public powers to govern the city, and public administrative agency to manage and supply public services. Also in the city, all these components are not well defined. So be careful. Okay, if I go into the detail, for the in this figure, the different levels of land are shown. They go from the local dimension, so the city, to regional, then you have the city network, then you have the national vision, and finally the global dimension. So we have to pay attention of these different levels because they don't function in the same manner at each level. Regarding people, it is too simple to include in the city perimeter only who reside in the city. Cities are daily interested by fluxes of workers and students living in the neighborhoods and reaching their own workplace or school or university. Moreover, cities are visited by travelers for work or tourism. I'm an example. Okay, concerning infrastructure, it is one of the most important aspects of the quality in urban space. Private and public buildings and their quality create the urban skyline and define the city character. Streets, traffic, public transport really impact on the quality of urban life, but infrastructure also have an important role in the quality of urban environment. Buildings and transport consume energy and produce pollution. In fact, they play a double role, both positive and negative, on the quality of the city. And the last one is the government. So it is urban policies that are defined not only at urban level, but also, remember, at the regional, national or global level. And therefore the urban area and its form are very fuzzy, and they change depending on the topic, the action, the project, and so on. So in this little figure at the end of the slide, we see the different level of urban policies and government. Okay, this is an example in Europe. Sorry, I'm French. But it's the same for all countries in the world. You have the public administration with the local rules, the local implementation. Then you have the central government, where you have national rules with some different policies. And then you have, okay, a more global dimension. Here, this is the European Union, but I think they have some priorities that are not possibly the same of the local implementation. Okay, so from our point of view, all these basic components of a city could be seen both from the positive and from the negative side, considering their impact on the urban quality of life. The city dimension could be the main driver of both the city's success and its problems. These two aspects, so the good and the bad one, of the city life are at present the most interesting drivers for the development of a smart city strategy. Indeed, we could consider that the metropolitan dimension of a city is a problem to solve, and on the other end, it is also able to produce attractiveness for better development. A smart city strategy can aim, in the meantime, both to face the negative aspects, so the threats, and to empower the positive ones, the opportunities for a greater dimension of a city. Opportunities in city are given by university where to study, companies and public bodies and organizations where to work, theaters, cinemas, libraries, concert halls, and all the public space where to catch cultural opportunities and spend time to free time in leisure sport. I don't know. The city is obviously a place where to live and a formidable place where to meet people. in the city ideas born, circulate, create initiatives and business. In city things happen. So how many initiatives could be really exploited and supported thanks to smart strategy? We don't really know. However, the presence of people, organization, business in the urban space is a treat for the daily life because inefficient local public transport, traffic, the high cost of houses and loans are some of the more diffused negative impact of the population identity in cities. Okay, pollution is a main characteristic of several large and medium cities with low rate of green spaces. The buildings use a high quantity of energy. The environmental impact is strongly negative, and the social differences, for example, especially in large cities, create poverty and social tensions. So could a smart city really make something against these problems? It is not for now very clear. And it's time to try to develop an answer to face the situation before it becomes too difficult to face. Somewhere, the idea to use the technology to support a better way of life in cities, especially in large metropolitan areas, begins to emerge, in fact. The use of high technology to shape the urban skyline is driven by the potential of the technology to enforce new strategies, initiatives, projects, and infrastructure aiming at improving the quality of life in urban space along different axes. You have a smart development that trend to create much economic value thanks to the use of better informed and linked people in business. You have the sustainable development by using technology to implement low carbon energy and economy, resource efficiency, sustainable transport, and you have an inclusive trend, which is by using especially information and communication technology, so ICT, to create social inclusion, civil participation, and the political debate with higher education and information quality. So the smart city ideas therefore follow a bottom-up path, growing from single initiative of business, non-profit organization, public bodies, local governments, university, and so on, aiming at using the technology to struggle against the menaces in large cities like pollution, energy shortage, water and air bad quality, poverty, social exclusion, and they want to create opportunities for sustainable growth, green cities, shared information, social communication of to have a higher quality of life in the urban space. So the smart city concept uses the technology, especially ICT, to improve the life quality in cities, to create economic development, to save the environment. However, okay, what is really a smart city? We think that a clear and sound definition of smart city lacks in the academic debate. But a well-conceived definition is necessary to drive choices and to increase the probabilities of success in a so difficult context. In fact, a lot of definitions exist. Here is just a very little example. From the literature analysis, it emerged that all these concepts are not in contradiction with each other, and they disclose some shared feature and are partially overlapped. We already seen a different definition by each keynote speaker. So here is just an example, and from our point of view, we retain the following definition, which is the closest from our vision. So this is the definition of Caraglio, where he said that cities are smart when investment in urban and social capital and traditional transport and modern ICT communication infrastructure for sustainable economic growth and a high quality of life with a wide management of natural resources through participatory governance. Okay, you can find the 4 elements I already present. So this is not this is an already existing one. Okay, so the Smart City ID was born in the 90s, but only recently it has become a current topic. There are 2 main reasons for that. The use of the word smart to indicate the so-called devices like smartphone, tablets, and so on. This is the one. And the other one is the impulse of national or international government to implement smart cities concept like low emission with the main aim to reduce CO2 emissions. Therefore, the idea of smart cities mainly focuses on the use of high technology to improve the quality of urban infrastructure and to reduce their environmental impact in the metropolitan area. So, for example, the European Union impulse is so strong to overcome all the previous academic visions based more on knowledge and human capital in city that on the environmental aspects. So depending on this vision, the basic components of the smart city, we go back to this figure. Okay, so regarding the land, the territorial dimension not even correspond to the administrative boundaries of a city. Sometimes a city extends its role of economic and social attractiveness well beyond its administrative boundaries. The Organization for Economic Cooperation and Development is developing a new way to define metropolitan areas using a methodology based on the economic function of the city rather than its administrative boundaries. Also, the political aspect is important. For example, in Italy, a deep reform of the administrative metropolitan area is underway, extending the administrative boundaries of large cities to the metropolitan area, interested by common public services and characterized by high population density and working fluxes from the neighborhoods to the city center. Sometimes cities link together to create city networks, to share best practices or face together deep urban problems. And not even these cities are contiguous, but perhaps they are similar in their own characteristics. Concerning infrastructure, this is always the most important aspect of the quality in urban space. So private and public buildings and their quality create the urban skyline and define the character of the city. Regarding people, remember we include who reside in the city and workers, students living in the neighborhoods and reaching their own place of school or universities. And tourism. About governance, urban policies are defined at different levels. We always have the regional, national, and global level, and the local one. And therefore, the urban area and its form are very fuzzy, and they change depending on what they have to do. Under the influence of globalization and the impact of information and communication technology that's modified radically our relationship with space and time, the city increasingly develops its activities in a planetary space with 3 dimensions. You have the global space covering the set of the cities where the nation. Then you have the local space corresponding to the city situated in a given geographic area, and you have what we call the space of influence that covers the field of interaction of the city with the other one. So the city locked up on its local borders is transformed into what we call an extending city without borders, open and adaptable. Furthermore, this extended city is placed under the ascendancy of the unforeseeable environment that leads towards uncertainty and doubt. This city meets fundamental problems of information exchange and knowledge sharing among, on the one hand, its formal entities distributed in the world, and on the other hand, the city's people, nomadic or sedentary, the same, bearers of diversified values and culture according to the origin. Okay, so two networks of information overlap. We have a formal information network between the internal or external entities in which circulate data and explicit knowledge. This network is implemented under intranet and extranet technologies. And we have an informal information network between nomadic or sedentary peoples. This network favors information exchange and tacit knowledge sharing. It is implemented through converging information and communication technology, for example, the new iPod, or I don't know, some other tablets and other things. The problem occurs when nomadic people, for example, tourists or students, placed in new, unknown, or unexpected situation, needs to get active information that are information and knowledge they need immediately to understand the situation, solve a problem, take a decision, and act. We need to help these people. So our reflection is nowadays, okay, ICT bear functionalities that bring uses, that induce organization, which needs a new vision of the city. And these uses also need a new vision of city. This is our reflection. And more globally, in fact, we think that city bears objectives that bring processes which need a new vision of the city. So the city needs to become smart city. In fact, our vision is bidimensional. There is an organizational dimension and a technical dimension. The organizational dimension is, okay, human tools who can collect, process, store, and disseminate information in order to support decision and process control. And the technical dimension is, in fact, an artificial object, and what we call an artifact. It's human-made, and this is the digital information system which collects, processes, stores, and disseminates information and knowledge in order to support decision and process control in city. When I say knowledge, is what you have in your head. Sometimes you can say what you have in your mind, but sometimes you cannot. This is what we call knowledge. So from our point of view, we have ICT that become more and more important, complex, distributed, and we need an information and knowledge. Information and knowledge are the heart of the smart city. And as a second role, we have cities that require more and more productivity, more and more quality with ever shorter developments. And knowledge can improve the decision process in the city because people are the heart of the city, they have the knowledge. So we can use it. We are sure that we can. So from this is just our point of view, but we want to use knowledge. So if I just say like a conclusion of our vision is that we need an information and knowledge center approach because we need to use this knowledge of people, and because knowledge can be tacit, it stays in your mind, and the part can be explicited. The approach needs also to be human-centered. We consider that the people are really the heart of our system. especially in smart cities. That was the first part. So now the second one. Okay, considering smart city, we have a lot of questions. And what are smart cities in practice? Where can we find smart cities? How to improve the smartness of a city? Okay, so I try to answer to these three questions. When we try to implement a smart city, it is important to produce investments to create sustainable development and better urban space. And the result are wellness and economic development. Of course, it is only possible with governance and management, both public and private, and of course, financial sustainability. As I already said, the concept of smart city is not yet clearly defined. However, it exists 6 categories, 33 factors and 74 indicators, okay, according to the work of Giffinger in 2007, to classify this kind of cities and to compare them. These 6 characteristics are smart economy, smart mobility, smart environment, smart people, smart living, and smart governance. According to Giffinger, so the author of this proposition, a smart city is a city well performing in a forward-looking way in these 6 characteristics, built on the smart combination of endowment and activities of self-decisive and dependent and aware citizens. Each characteristic is therefore defined by a number of factors, 33. Furthermore, each factor is described by a number of indicators. So finally, we have the 6 characteristics, the 33 factors, and the 74 indicators. Okay, for example, for a smart environment, so the green case here, the smart environment is linked to natural resources, in fact. So there is attractivity of natural condition. You can find pollution, environmental protection, sustainable resource management. And for this characteristic, so we have these 4 factors, and we have 9 indicators. Okay, this is always green. So we have indicators like sunshine hours, green space share, summer smog, and so on. So this is what we have to speak about smart cities in the literature. Actually, we can find smart cities in real life. Here it is, okay, European example, sorry. I take 4 cities that are considered as smart cities in Europe. Okay, I will think about Manchester. This is in United Kingdom, and they have around 500,000 inhabitants. Then we have Amsterdam, the Dutch capital, which have around 1,100,000 inhabitants. Then Barcelona in Spain with 1,600,000 people. Okay, and Malmö in Sweden, where there are only 350,000 inhabitants. This is a small city. Okay, just few words. The Manchester Smarter City program has been developed to explore ways of making the city work better through use of technologies. The program takes things that the city is already doing around transport, health, environment, and energy efficiency, and aims to encourage further advancement through supporting pilot projects and working with partners in universities, business, and public sector. New technology might include sensor, LED lighting, smart ticketing, low carbon technologies such as electric vehicles or solar panels. And new way of working includes ensuring the integration of different systems through common standard using big data to help to manage the city in real time, encouraging new applications and services to provide real-time information for residents or workers, and better use of information to help policymakers. So Manchester Smarter City focuses on 6 key terms to give better outcomes for the city and its citizens, and provides those projects and places that are contributing to the smart city. They have live, work, play, move, learn, and organization. The second smart city is, for example, Amsterdam. In fact, Amsterdam Smart City is an innovation platform for a future-proof city. This platform is constantly challenging businesses, residents, the municipality and knowledge institution to test innovative ideas and solutions for urban issues. This contributes to the livability of the Amsterdam metropolitan area. They promote sustainable economic growth and they help to develop new markets. And Amsterdam Smart City believes in a livable city where people can live and work pleasantly. And they have 6 different terms, which are infrastructures and technologies, energy, mobility, circular city. Okay, circular city is moving from linear to a circular economy. That means minimizing the waste and pollution by reducing, recycling, reusing, and so on. They have another point, which is governance and education, citizen and living. And the last one, this is the Smart City Academy, because they are very proud of all the projects they have, and our organization that arise from this platform, and they contribute really to future-proof and their livable city. And they want everyone to learn from this expectation, this experimentation, and so on. Therefore, they started what they call the Smart City Academy. Okay, Barcelona. I try to say nothing bad. Okay, for some years, just a few words. For some years now, Barcelona has been aiming to become a world reference in terms of smart city in Europe, in fact, and maybe all over. They try. And the management team reinvents the city and multiplies the connected services. They have lighting, smart lighting, advertising, WASP for citizens and businesses by placing the new technology. They use cloud, they use big data, and so on, at the heart of their project. The last one is Malmö. So this is in Sweden. So they have in Sweden they have the Smart City Sweden. This is a national export and investment platform for smart and sustainable city solutions. So they have that for all the city in Sweden, and the best student is Malmö, where they focus on air quality, recycling, water, biogas, transport solution, bioenergy, and waste to energy. They are well known to produce energy with their waste. So, for example, Malmö is saving money and energy by investing in greener ICT products and solutions. As a signatory of the Eurocities Green Digital Chart since 2010, I think, Malmö has committed to decreasing the direct carbon footprint of its ICT infrastructure by 30%. It's enormous. By 2020. And the city's green ambition were nationally recognized in 2013 when Malmö reached the impressive level of 98% of environmentally labeled ICT products. It was the first one to do that. So new higher standards for the green procurement of ICT products were introduced by this city, and they are estimating to be saving over €500,000 euro per year. It's incredible. This is, for example, of a concrete smart city, if I can say something like that. So now we know what, we know where, but one question remains: it's how. How to do that? How can they become smart? What they done? Okay, so being smart is a challenge increasingly important for many cities or communities. This is of particular interest in the domain of ICT and for such systems where there are economic, social, and other issues. To the best of our knowledge, there are no studies that attempt to help identifying the actions to be implemented to improve the smartness of a city. And we attempt to fill this gap by recommending actions. It is an emerging and, I hope, promising field of investigation. So I will explain theories about what is a recommended system, and I will present our proposition of recommended system for smart cities. Okay, so what are recommended systems? Recommended systems are a particular form of information filtering designed to present information items like movies, music, books, images, web pages, and so on, that may interest the user. Recommended systems have been studied in many fields, like cognitive science, information retrieval, web, e-commerce, web usage mining, data warehouse, many others. And the goal is to enhance user experience by assisting users in finding information and reducing search and navigation time. So the problem of recommendation can be summarized by the problem of estimating scores or rates for items that the user have not seen by now. Indeed, the number of items and the number of users of the system can be very important. This is a kind of big data problems. And it is therefore difficult for each user to see all items in the catalog, and that each item is evaluated by all the users. So it is therefore necessary to estimate the scores for items not yet evaluated. Okay, this is an example. Intuitively, the valuation, okay, to predict the values, is usually based on the scores given by a user to other items and other information that I will formally describe below. When it is possible to estimate the scores for items not yet evaluated, then the items with the highest scores may be recommended to the user. For example, here we have the heart of the recommended system, which is what we call the utility matrix. This is a matrix where we have users, and here this is movies, sorry. And okay, you have the cells of this matrix that correspond to what we call the utility score given to the movie by the user. So for example, John really likes the movie Harry Potter because he gives a score of 9. The maximum score is 10. And Maria, for example, for the same movie Harry Potter, she doesn't really like because she gave only 3. More formally, Hill, okay, this is the definition at the end of the slide. It formulates the problem of recommendation in the field of e-commerce. It was the first definition we have of recommender system. So, given the set of all the users you can have in your system, and the set of all available items, the one you have, for example, in the catalog, and this is the utility function. So for of an item for the user, so like this matrix, choosing the item S' not yet evaluated. S' is in the set of available items. That we have to maximize the utility for each user. This is the formal definition. In fact, this matrix is obtained, and some other information are obtained through the user profile. Mohan at the beginning of the week speak about that. This is the basis of recommender system. This is the user profile, which contains tastes, preferences, and needs of the user. In fact, there are explicit data and implicit data. Okay, what we call explicit data is when the user provides information about its preference. Okay, I like that, I don't like that, I want that or not. And implicit data, it's when we have to infer whether or not the user likes products based on its behavior. Okay, because I don't know, every week you go to the website and buy this item, we think that we like this. This is inference. Okay, according to the user profile and the utility matrix, classically we have three kinds of recommender system. This is based on collaborative filtering, we have content-based recommendation, and we have hybrid approaches. So for the collaborative filtering, okay, we can make a sentence like, tell me what's popular among my peers, and by using the user profile and some contextual parameters, and of course the community data, we put that in the black box recommender system, we check, and we obtain a list of recommendations. The second one is content-based recommendation. Okay, the sentence could be, show me more of the same what I've liked in the past. So we use only the user profile and the contextual parameters, and we use also the product feature, so some information about the items. Okay, we put that in our black box recommender system, we check, and we obtain a list of recommendations. And the last one, this is the hybrid one, which is a combination of various inputs and composition of different mechanisms. So we use all we can. The user profiles, the contextual parameters, the community data, the product feature. You can find some knowledge models and so on. You put that in the black box, you check, and you obtain a recommendation list. I will explain what is inside the black box. No worries. Okay, so I will make some details on each approach. Okay, so for the collaborative filtering, the same figure. So the underlying assumption of this approach is that those who have accepted or liked in the past tend to accept again in the future this kind of item. Systems based on collaborative filtering output recommendations by computing similarities between preferences of a given user and preferences of the other users of the system. Such systems do not try to analyze or understand the content of the items. They are able to suggest new items to users who have similar preferences. This method consists, in fact, in proposing automatic forecasts, like a filter, based on the user interests, by gathering opinions of many users, like collaborators. And the idea is to predict the user opinion that he will have on different items to be able to recommend the best item for each user according to previous tests or opinion of the user and opinion of other users that are similar to him. In collaborative filtering, there exists two approaches. We have user to user and item to item. Okay, user to user is when recommendations are made by finding users with similar tastes. So, for example, here we have Jane and Tim both liked the item 2 and disliked the item 3. It seems they might have similar tastes, which suggests that in general, Jane agrees with Tim. So we can use this information to say that item 1 is a good recommendation for Tim because Jane liked item 1. So this approach functions easily, but it does not scale for millions of users. We have a problem when we have a big data problematic for that. And the second approach is item to item, where recommendations are made by finding items that have a similar appeal to many users. Here, for example, Don and Sandra are two users who like both item 1 and item 4. And that suggests that, in general, people who liked item 4 will also like item 1. So, item 1 will be, for example, recommending to Tim, who liked also the item 4. Note that this approach is scalable to millions of users and millions of items. So this is the more used method in recommended system based on collaborative filtering. Okay, in collaborative filtering, there are some classical use methods, like because it's based on user similarity, we use methods like Pearson correlation coefficient, cosine similarity measure, or singular value decomposition and matrix factorization. To find the neighborhood of a user, we use, for example, neighborhood Bayes algorithm like the KNN. And for the rating prediction, because we have to find the value that's for items that have not already been evaluated, we have the latent semantic analysis or association rules and some others. I don't give some details. We have already seen during the weeks some proposition. The second approach in a recommended system is the content-based approach. So remember, we have the user profile and the contextual parameters, the product feature, and we try to find some recommendation. So this approach tries to recommend items similar to those users preferred in the past. So here, again, the user profile, the user preferences are the key. And the idea is to make matching between the user preferences and the item characteristics. Okay, a little example. So we have a user who reads the book Harry Potter, and it updates the user profiles. Then the recommended system makes a matching between the catalog of books and the user profiles and can propose some recommendation. So, for example, here, the next Harry Potter, I don't remember the number of Harry Potter that exist, or similar books, Twilight or I don't know why, for example. So, in content-based approaches, the classical use methods are, for example, the TF-IDF, cosine similarity and clustering for the similarity view between the items and the user preferences. And in fact, they are designed mostly to recommend text-based items at the beginning. Because the content of this system is usually described with keywords. And the last one is the hybrid one. Okay, so you take all you can and you try to find a recommendation. So in fact, there are many ways to combine different approaches to obtain hybrid. So you can combine a separate recommender, like linear combination of the two outputs. You can add the content-based result to the collaborative model, or you can add the collaborative result to the content-based model, and so on. There are many ways to obtain recommendation. Of course, depending on the application, the result will be different, and the combination is different. Okay. Of course, there exist other approaches like knowledge-based approaches, context-based approaches, social-based approaches. There are kind of hybrid approaches because they use a lot of different inputs, and the problematic of big data is in this kind of approaches, because you have more inputs, but we have a lot of problems to analyze or to treat this kind of data. Okay, as each system, we need to know if the recommendations are relevant or interesting for the user. So, of course, we use evaluation metrics. Just few words, because this evaluation has to answer questions such as: is the recommended system efficient with respect to a specific criterion, like accuracy, user satisfaction, and so on? Do customers like or buy the recommended items? And other questions that we have to answer. And we use metrics, really classical metrics, like the recall and the precision, the F measure, which is a combination of recall and precision. We have rank score, regarding if the scores are in the good order and if the value are good for the recommendation. The most used are the mean absolute error and the root mean square error. And of course, we have the problem of sparsity, because as I said at the beginning, the utility matrix is the heart of the recommender system, and sometimes this matrix is sparse. So we need to do what we can with this kind of data. Few words on the relating word on recommender system for smart city. There exist research works combining recommender system and smart cities, but they focus essentially on services. For example, there are some papers on mobility in smart cities, so they recommend services for mobility. We have e-governance services. We have recommendation of e-election, how to prepare the election, for example. We have public administration services recommendation or urban environment recommendation. But what we want to do, our proposition that we'll present just after that, is different, because we don't want to help for one service. We want to help the city to recommending actions, what they can do as services, urban environment, and others to be smarter. Okay, so remember, due to the fact that the concept of smart city is still not clear, and that this concept is emerging and has been developed in numerous publications, there are not really studies that attempt to help identifying the actions to be implemented to improve the smartness of a city. So recommending such action is emerging. So being smart is an increasingly important challenge, and our base, we base our work on the characteristic of Giffinger. So the 6 characteristics with the 33 factors and 74 indicators, and the corresponding actions. In fact, the actions have created knowledge on their effectiveness or relevance and how to implement them. So we present how to set up a recommended system for cities. Cities can be seen as a kind of a social network where citizens, decision makers, and different stakeholders interact through different canals with different interests and opinions. And our goal is to use the experiences of smart cities to help cities that want to improve their smartness by implementing appropriate actions. Okay, just a little definition to be sure that you understand what I want to do. So, by analogy with the definition of ill in e-commerce, we can define our recommendation for smart cities as an action, A, among the set of all possible actions to implement, such as its utility for a city, C, among the set of all possible cities, is maximum. So, what action have been already implemented in cities that are smart that I can use in my city to be smarter? Okay, so here we have the same matrix with city and action. And in our modelization, we need to see a city as a tuple containing the city description and the city information. Okay, this is maybe more formal. Okay, where the city information is a set of smart categories among the 6 categories are already present. We have for each category a set of factors, and for each factor the set of corresponding indicators. And of course, for each, we can specify for each indicators the values and the corresponding action that have helped to obtain these values. Okay, how do we process? Okay, we make a, I don't have the time to list all these hypotheses, but we make some hypotheses to be sure that we can use this kind of system, because we have a problem with smart city. We have a problem because we don't use only text, but also numerical or so on. So here we make some assumption to be sure that we can have the data, because we already said that about urban data, open data, and so on. It's complicated sometimes. And here we focus on indicator values that are numerical for the first step. So the framework we propose uses both the characteristic of the city, which wants to improve its smartness, and a kind of log containing for each smart city its category, factors, indicators, and implemented actions. And it consists of 3 following steps. So the first step consists in pre-treating indicators of the smart cities into the log according to the category of smart city chosen by the city, which wants to improve its smartness, what I call the current city. The second step consists in comparing the indicators of the current city and the ones of the log smart city and extracting the corresponding actions. And the last step consists in ranking the candidate actions. Okay, I can illustrate very briefly. The proposition with the example, okay, of course data are synthetic. Suppose that there is a log containing some information about 2 cities, Smallville and Metropolis. And suppose that the city named Gotham wants to improve its smartness for the category smart environment. Okay, this is an example of data we can have. And we suppose that the corresponding utility matrix is the one here. So, for example, Smallville consider that the action A1 is very interesting and give a score of 9. A1 is after midnight, shut down the public fountains. Okay, so the first step is to pre-treat function that outputs for a given category and for each indicator of each factor an interval of values. So, for example, here, if I only take the value of Smallville and Metropolis, because there are only 2 cities, it's easy. So I obtain some interval. So, for example, we have 300 for the water consumption of Smallville and 100,000 for Metropolis. So we obtain the interval. We make the same for each factor and each indicator. Then we have a matching function which returns the set of action implemented by the candidate cities like Smallville and Metropolis that correspond to the indicators where Gotham's values are out of bounds. So here we have Gotham for the water consumption is out of bounds, but for electricity consumption is okay. So we the candidate action that can be interesting according to Smallville and Metropolis for the indicator water consumption is A1, A2, and A3. So after midnight, shut down the public fountain. A2 is do not water plants during summer, and A3 is after midnight, do not wash cars during summer. This is just some example. And finally, these candidates' actions have to be ordered. So, for example, in this example, they can be ordered according to the ease of implementation. For example, we can consider that it's easier and faster to decree that public fountains are to be shut down after midnight than to force people to not use water during summer. So a possible other set of action to be implemented in Gotham, for example, to improve its environmental smartness is first try to make A1, then A2, then A3. So we obtain the corresponding utility matrix where we predict some value rates for A1, A2, and A3 for Gotham. Okay, I have 5 minutes for conclusion and perspectives. Okay, from our point of view, knowledge is the key to improve the smartness of a city. Knowledge is what citizens and all people that are around the city and their knowledge, because they are the heart of the city. And for that, we want to take into account knowledge as much as possible, share and reuse it. And our proposition is to recommend action in such a way. We propose a kind of recommended system because given some information on smart cities and using knowledge of people in the city, our framework tries to return some action to implement for a city which wants to improve its smartness. Okay, this is a work in progress, and it is, for now, a theoretical approach. But our future work includes real cases with experts, in fact. We are aware that in some evaluation it is possible to expect a bias because we are in human actions. And our main objective is to propose a digital information system for decision head. The final decision is, of course, done by decision makers and must be taken with all the stakeholders, taking into account economical, social, financial aspect, and all the stakes in this kind of project. First of all, we think that we need a standard definition of smart city. Second, we based our work on the classification of Giffinger, focusing on medium-sized cities and on the analysis of characteristics and factors decisive for a successful forward-looking city development using data from official, public and freely available sources on the basis of the 74 indicators. But other classification exists, thus standardizing these indicators will be necessary. Third, we want to elaborate a more sophisticated recommended system by combining approaches based on content, collaborative filtering, context, knowledge, web, and what we want, because this is the big data area, and urban data are very, very heterogeneous. And for example, we want to take into account the concept of multi-criteria analysis, because it is not only one way to decide, and some group decision, because the city is kind of group. Okay, and of course handling big volumes of data. Finally, from our point of view, the expression smart city covers all the managerial action aiming to answer the problem of smartness of city in general. For us, it is necessary to align the management and strategy orientation of the city, to make people sensitive, because if they don't play the game, it is not necessary to do something. To motivate all the stakeholders of the city, to organize and to pilot activities and specific processes leading towards more mastery of smartness, to arrive the implementation of favorable conditions to the cooperative work and to encourage the sharing of knowledge, to elaborate indicators allowing to ensure the follow-up and the coordination of launch actions, and to measure results and to determine relevance and impact of these actions. So the question is, to be smart or not to be smart? This is the Darwinian evolution for cities. Thank you for your attention.
Thank you very much. We have a nice time for opening the floor for questions. Yes, please. Here we have a question.
Just go back to the recommender systems. In the recommendation, you have some items. 1, 2, 3. Yeah, this is classical problem of a recommendation system. And I'm wondering, is there any specific things, specific problem that is brought by smart cities, or when handling smart cities? When you do recommendation, that means if you have any system, any approach based on a recommendation, you will implement it and it will work.
The real problem in smart cities is the access to the data, in fact, because here we consider that we have a utility matrix, good, but I'm not sure that City 1, City 2, City 3 and City 4 give us the information that this action was good, this action was not good. Why? Because there are some economical issue.
But they have it. You are using it.
We consider that we have it.
So you have it.
No, this is a practical problem to obtain this, because more information we have, more dense is the matrix, and it's easier to obtain better recommendation. The problem we have here, we try to make some experimentation with the data from Paris, because we have a cooperation with the mayor of Paris, the city hall, and it's to say that it was very complicated the access to the data was complicated, and they the governance of this kind of action is not really done like a head, and you have the head and the hands to do that. It's different services, different communities, and so on that make some different action, and it depends on the project and the goal and so on. And it's very, very complicated to have a really good set of data and deployed on all different action and different factors that we have. It's complicated to obtain the data. This is really the real problem.
Okay, that means as it's complicated to get data, your matrix is very sparse.
Yeah.
Therefore, it's quite difficult to do recommendation in that
and one
case.
problem when we have sparse matrix in recommended system is what we call the cold start problem, and the recommendation are not very good at the beginning. So this is a real problem to have enough data to be sure that the recommended system can process effectively.
My second question, really quick.
You have a second question. Now he has a lot of questions.
Why that in your in the last slide in your conclusion?
Yeah.
Why you want to have? Why you want to disambiguate the smart city word, smart city concept? I think it's we know what's behind smart city.
We don't really know, because depending on
You showed some
your
example.
application.
You showed some example, and there are some town which was built from scratch. For instance, Songdo, I think, from in Korea.
Yes.
So there are some example. And do you think they need to disambiguate the word to build such city or not?
I think before doing the city, yeah, I understand, but I think before doing the city, they need at the beginning to make a definition, or if you want to modelize something, you need a definition.
And then you jump into the
Sorry, I'm
water.
French.
Do you have other questions here?
You said that the problems is the access of the data, how to generate data. In the first part of your talk, you said that there is many domains. Maybe you can discuss a little bit more in the afternoon during the panel. There is transport, environment, security, and so on. From your point of view, in which domain one city can start in collecting data? To what's in your point of view? What's the priority to start collecting data? In which domain you can? That there is some domain that it's easier than others. So, and the citizen wants to see that his city is smarter. So, how to start collecting in which domain?
Okay, this is just my point of view.
Okay, we can discuss a little bit more in the afternoon.
I think because smart cities come from what we call smart grid, the more available data we have is about buildings, transport. During the week we saw a lot of presentation about urban data, but it's more about transport and buildings than, I don't know, a public space or green space or something else. So because the technology are implemented in buildings and transport and captors and sensors and so on, I think this is the first step. We can start by that because we already have the possibility to obtain the data. But it's just my point of view. I'm not sure that a policymaker will agree with me.
Other questions? I have one question. Since we're here, are there studies that integrate cultural dimensions to the choice of strategies in order to become smarter? For example, some month, I think ago, there was in the news in France a documentary explaining that regarding garbage, it was very difficult to implement a selection of garbage in France as in other countries because people do not adhere to this action. And so I think that in smart cities, and in your last slide you said that you have to invite people to adhere to the action. Are there recommendation systems or studies that try to consider this kind of cultural profile so that people can participate actively in such kind of action?
There exists works on cultural approach for this data. Okay, not in France because we have a big problem with cultural implication. But I think in the north of Europe, like Norway, Sweden, and so on, they have no problem with cultural difference. Maybe if I can say something like that.
Well, they have accepted in Germany. They are accepting.
Yeah, also,
a lot of immigrants.
For example, for smart city, the north of Europe is better than the south of Europe.
I don't know.
From what I read, it's what I can understand. And in the topic smart city, it's just the beginning of the cultural implication. But if you take others topic less related, like crisis management, for example, they have already make some work on the cultural impact on the preparedness for crisis, for example. And I think we can maybe use some of existing solution in this area to the smart city, because I think there are some related problems in smart city and crisis management.
I was also thinking about age gap. You know, smart cities are based on technology, and yet, at least now, maybe in later years not, because people will be used to using technology. But now there's an important gap among generations. So you could have a big sector of your citizens that do not adhere because they do not use technology. They are scared about technology. Again, are there studies doing it?
There is a beautiful example in France, Nice, which is one of the smarter city in France, because they have a lot of captor, sensor, and so on. They have a lot of e-access for administrative things and so on. And this is, I think, if I don't make a mistake, the most aged, the most older, because there are only old people in this city. Yeah. So I'm not sure that this is a real problem.
Okay. So you feel that the generational gap wouldn't be a problem in order to develop a smart city strategy?
For me, I don't think this is a problem. For example, if you take Japan, they all live together, but the population is older maybe than in our places, and they don't have that. For example,
in Japan the generations are mixed, are living together, whereas, for example, in Europe the generations are not living together. So these kind of things might be interesting to consider. Yeah.
I'm not sure that it can be a problem, because I already seen an example in France, which we disagree to all. But I think it's not the major problem. Maybe it can be one, but I'm not sure this is the major one.
Okay.
Wait and see.
Other questions? Last one. If there's somebody in the floor, don't be shy. Well, if there's no question, I am going to close the session, and I am going to invite you to the last session after lunch, because there it will be the opportunity of the floor to be very participative. We're having a panel on like hot issues of smart cities, and so we invite you to come and participate in the discussion. So have a nice lunch, and see you later. Thank you very much.